This is problem 25 on your midterm review, and it looks a little different than the other ones that we did, but I promise it's actually easier. So the question states, the function above models the height h in feet of an object above ground t seconds after being launched straight up in the air. At how many seconds after launch does an object fall back down to the ground? We're looking for our answer in seconds. Let's have a look at this equation. If you were to graph this equation, it would look something like this. Our c value is 0, so our y-intercept is at the origin, 0, 0. And that makes sense because it sounds like from the description of the problem that our object is being launched from the ground. Like all of the other projectile problems that we've done, the x-axis represents the ground. So this first intercept represents the point that it's launched, and the second intercept represents the point that it lands. And at both of these points, because it's the x-intercept, our y is going to equal 0. So the way we're going to solve this problem is to find out at what point does this equation equal 0. There are two t values that you can use to make this equation 0. And you may be able to tell just by looking at it what one of those values is. And I probably don't have to show you this, but I'm going to anyway, just to be thorough. Here you see I've replaced the t values with 0, and what I get when I multiply these out is negative 16 times 0 squared plus 128 times 0, which is just 0. And now we have to find the second t value that will give us 0 for the value of this equation. And I'm going to start by factoring a t out of this equation. When I factor a t out of negative 16t squared plus 128t, I'm left with negative 16t plus 128. And now I want to get rid of this t so that I'm left with only what's in the parentheses. The way that I'm going to do that is by dividing both sides by t. And you see that when I do that, on the right side here, I can cancel out these t values, and I'm just left with what's in the parentheses. But on the left, I have 0 over t, which is just 0. Now, when I rewrite this equation, I'm left with negative 16t plus 128. And all we have to do is solve for t. I'm going to start by subtracting 128 from both sides, and I'm left with negative 128 equals negative 16t. And when I divide both sides by negative 16, I'm left with t equals 8. So that means our object falls and hits the ground at 8 seconds.